Hello, in this video we're going to learn about vector operations. The first operation we're going to learn about is scalar multiplication. If you remember back to multiplying matrices by scalar, this is practically the same thing. So if I give you the vector 2, 4, I want you to find 1/2 u, negative u, and 2u. So let's go ahead and let's start with 1/2 u. So we're going to multiply the entire vector u by 1/2. So we're going to distribute this 1/2 in. So 1/2 times 2 is 1, and 1/2 times 4 is 2. That's a terrible angle bracket, but you see the picture. Okay, next, what if I want to find negative u? We understand that negative u is the same thing as negative 1u. Therefore, I need to multiply the entire vector u by negative 1. So 2 and 4 by negative 1. Once again, I'm going to distribute that in. So negative u equals negative 2, negative 4. Lastly, if I'm finding 2u, I need to multiply the entire vector u by 2. So 2 times 2 is 4, and 2 times 4 is 8. So that is the vector 2u, and I did not write the 1/2 u here. So we can see our three answers. 1/2 u was 1, 2. Negative u was negative 2, negative 4. And 2u was 4, 8. If we want to graph these, okay, remember the first number is our x portion, and the second number is our y portion. So if we're graphing, let's graph u to begin with. We're going to graph u in red. U is 2, 4, so out 2, up 1, 2, 3, 4. Remember, because this is written as a component vector, that means the initial point is at the origin. We'll sketch that out. So there is u right there in red. We can graph 1/2 u in green. That's going to be out 1, up 2. So there is our vector there. And negative u, we're going to graph it in a lighter blue. So that's going to be negative 2, negative 4. So we can see that this vector has simply been reflected over into quadrant 3. And then I'm going to graph the last one in this purple color, and that's going to be 4, 8. Out 1, 2, 3, 4, up 8. So now we can see that this vector is just double the length of the original vector that I drew a little bit too long. Got a little carried away with myself. Okay, so those are the three vectors. Just remember that vectors are array. They're a special kind, but essentially if you want to relate them, if you want to relate vectors to something you've already learned about, you can relate them to arrays and matrices. Okay, what about vector addition? So we have the vector u is 3, 4, and the vector v is 4, 1. We want to add these two things together. So just like matrices, we are going to add corresponding spots. So 3 and 4 are both the first spots. They're both the x, or the horizontal portion of the vector, and 3 plus 4 is 7. Next, we need to add 4, the y component, with the other y component, which is 1. And 4 plus 1 is 5. So u plus v is 7, 5. So if we want to look at this graphically, we're going to graph u in red and v in blue. So u is out 3, 1, 2, 3, up 1, 2, 3, 4. Okay, now here's the really cool thing. So I know that that v is 4, 1. So out 1, let me change colors. out 1, 2, 3, 4 up 1. But if I take this vector and I move it out 1, 2, 3, 4, 1, 2, 3, 4 up 1 here, watch what is about to happen. So I just moved that tail end. Watch what happens whenever I graph u plus v. So u plus v is 7, 5. Out 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4, 5. Guess where I just ended? Ooh, that was terrible. We're sketching, guys. Sketching, sketching, sketching. Please excuse my drawing. We ended right where we ended whenever we added v onto u graphically. So how cool is that? That's what vector addition actually means. All right, let's do one more example. This is going to be vector subtraction. We have u, which is 5, 4, and v, which is 2, 6. We're going to subtract them in the same manner that we added, meaning we're going to subtract corresponding spots. So 5 minus 2. 5 minus 2 is 3. Next, we are going to subtract 4 and 6. 4 minus 6 is going to produce a negative 2. So u minus v is now 3, negative 2. So that concludes our video on matrix vector operations. Hopefully you realize how similar it is to our matrix operations. In the next video, we will begin multiplying and doing things that are more complicated. So I will see you in the next video.